Hey guys, welcome to today's lesson. Today we're looking at area of triangles, quadrilaterals, circles and sectors. So generally it's a review of your area formulas from year 7, 8 and 9. So your area formulas, let's go quickly through that. Hopefully you should know these formulas by now. If not, of course, then make sure you go home and learn them. So we have area equals s squared. Now you can also say base times height or side times side, but of course because the square has equal sides, we can just say s squared. Rectangle, I'm going to use base times height, length times breadth, length times width, whatever you want to have. Triangle, area equals half times the base times the height. Base times height divided by 2, lots of different things you can have there. A parallelogram, now remember parallelogram looks like that. Okay, opposite sides are parallel and are equal, so it looks like a rectangle shifted over. Remembering that we can cut it off there and we can post it there, which means the same as a rectangle, so it's base times height. The trapezium is usually the one that a lot of boys do struggle with. There's a couple of ways we can write that. We can say half of h a plus b. That's the form that the formula sheet usually has. I probably prefer the a plus b over 2 times by the height. Again, remembering that a trapezium has one pair of opposite sides that are parallel. Basically, it's kind of like a rectangle, right? And you find the average length of the sides because they're not the same. So there your a and b. So the average of those two sides added together would be a plus b divided by 2. And you then simply times it by the height like a normal rectangle. But either version is fine. Circle, by now you should know that from year 8, of course. We have pi r squared. A sector, okay, which is a part of a circle, is that theta over 360 times pi r squared. And then your kite is half times xy. Okay, now remembering for a kite, you have adjacent sides are equal, and your x and your y are going to be those diagonal lines. So it's half times x times y. That's majority of your area formulas, of course. There might be a couple other ones there that pop up later on, but certainly of a 2D shape, they are the most of the area formulas that you will need to use. Now, I've already spoken in a previous lesson about converting area, so this should be reasonably okay. Remembering with converting area, kilometers to meters to centimeters to millimeters, it's very similar to converting measurement units, okay? So we remember if we're doing the measurements like this, we would say times 1,000, we'd say times 100 and times 10, and then divide by 10, divide by 100, and divide by 1,000. Now, when we're doing area conversions, it means we have those units as squared, so we need to ensure that we square these measurements. You might remember back to 2 lessons ago, we spoke about the 1 meter square. Therefore, the area equals 1 meter square. If we do that in centimeters, of course, we get 100 centimeters and 100 centimeters, which means we get 100 times 100, which is 10,000 centimeters squared, which means that conversion rate is 1 times 100 squared. So that kind of proves that whole point that you need to square those conversions. Just be careful too, don't square the actual measurement. So for example, if you've got 5 meters to centimeters squared, don't do 5 squared times 100 squared. Be very careful there. It's only your conversion that you're squaring, okay? You're not squaring the actual measurement as well. And that's one of the mistakes a lot of boys make. So in this case, we got 1 meter to centimeters. Well, that's just a measurement, so that's 100 centimeters. 1 meter squared to centimeters squared. Okay, it's 1 times 100 squared, which we know to be 10,000 centimeters squared. We have 5 centimeters squared to millimeters squared, so 5 times 10 squared, which equals 500 millimeters squared. We get 1.5 kilometers squared, so 1.5 times 1,000 squared. Now, of course, you have calculators for this all the time, so you may as well just do it on there, but 1,000 squared is a million, so we got 1,500,000 meters squared. Now, let's reverse it. We're going to go 5,000 centimeters squared to meters squared, so we're going to do 5,000 divided by 100 squared. In other words, we're saying 5,000 divided by 100,000 cut those zeros off, we get 5 over 100, which of course is 1 over 20. Let's actually put it as 0.05 meters squared. Beautiful. Now, the last one I wanted to look at, because it's one of the ones that we are expected to know, but we don't talk about it too much, and that's when we have a really big area, okay? A hectare, so 1 hectare, known as a HA, that equals 10,000 meters squared, which is important. So in this case, we have 50,000 square meters for our particular hectare. So just be careful about your hectares as well. We don't use acres, by the way. That's American, not Australian. Okay. Now, the last two is some measurement questions where it's looking at the area. I've looked at a few harder questions because the easy ones you should be able to do. Now, of course, this question here, I'm going to look at this thing. We've got a nice square of side 10 centimeters. So we know that area 1 will simply be 10 by 10. Okay, area 1 equals 100 centimeters squared. That's the easy part. But area 2, of course, we have a half of a circle. Now, what's my radius of this circle? My radius is going to be 5. So half times pi r squared. So area 2 equals, well, 5 squared is 25. So it's 25 pi on 2. Okay, so my total area equals 100 plus 25 pi on 2 centimeters squared. Now, of course, we might be asked to do significant figures or some sort of rounding. So I'm going to put there 100 plus, I'm going to type my 25 over 2. And I've got my pi in there. Sorry, it's a little bit slow. Okay, so we get approximately 139.2699 ... which would be 139 centimeters squared to 3 significant figures. Okay, so again, that's pretty important to have a look at. All right, B, bit more challenging. Okay, this case, if I kind of make this into a square, okay, now we know that little bit there is 5, which means they're 5 and they're 5, so we have a square of 5 times 5, which is 25 millimeters squared. So the whole area is going to be 25 millimeters squared. Now, in order to get the part inside that square, what we've actually got, we've got these quarter circles, and we've got 4 of them. 4 quarters make a full circle. So what we're actually doing, we're going to look at area 2, which is pi times, now the radius is 5 squared, which equals 25 pi. And to get my total area, we're going to say the whole area of the square minus the area of the actual circle. Okay. And that should give us, now, it's going to be checking. I nearly made a mistake there, didn't I, boys? Hopefully you picked it up. The square is 15 centimeters or millimeters long. So 15 by 15. Okay, be very careful. I worked that out though, because I figured out that I was taking away a bigger area than I had. So that's 225 millimeters squared. Ooh, that was close. So let's do a 2 there. Okay, so now we're going to take away the 25 pi. Notice how I often leave my measurements in exact form. I think that's a really good thing to do for measurements, so then you only have to round the last step. So my area equals 146.46 ... which equals 146 centimeters, or sorry, millimeters squared to 3 significant figures. All right, gents, that's pretty much it. I know it's a fairly quick lesson. Area of triangles, quadrilaterals, circles, and sectors. Go and learn your formulas. You need to know those things off by heart. Yes, some of them on the formula sheet, but you should know them. Make sure you understand your conversions of areas. Okay, that's really important too. And then, of course, your actual practical areas. I'm going to do a lesson also on significant figures, because I just noticed that I haven't really gone through that with you, and that's probably not a bad thing to do as well. Have a great day.